Hello, everyone. I hope you had a nice weekend. Let's transition to the code view. Today, I'll be working on the simple parser that I started last week. You can see that I've done a little bit of experimentation over the weekend. It is a very simple parser, which translates or parses expressions like this. I just need to polish it up a little bit for these lists of skewer blocks. So I already have a loop that returns types like these. I just need to put together all these expressions and translate them into a list of skewer blocks. So I hope you have your coffee or tea or whatever you like ready, and let's write some code. So as you can deduct from the type signature, I'll be folding all my either results from the loop function. I'm going to try to put them together into a single either type that's that will hopefully extract a list of skewer blocks. The function is already reduced. I can't use the left because then I wouldn't be able to combine it with anything. Okay, let's see what the what AI suggested. So technically this is not relevant. Oh no, sorry, that was correct, I think. That is a lot of errors. Okay, one at a time. Two nine six. Right, let's take it a bit slower. I'll remove this part, and here I'll just return the accumulator. Okay. So it is telling us that the reduce is not needed. Okay. Sorry, reduce. Reduction is needed, so we need to reduce. Okay, and let's try to gradually incorporate this. Just for now. Okay, it still builds. Let's take it step by step. Now let's break this right up into nothing and just. Still compiles. Still compiles, that's good. I must have had the indentation correct. Otherwise, I don't know what was wrong. But either way. This is the old one. Let's try to parse the new one. Oh, and I still need to apply ABC on the loop result. So what we need here is ABC applied to the loop results, and loop we execute with I think. Let's see. Mm-hmm. So this now should just be replaced with an action according to my new input. And it does. So let's see if we can have two actions. And would the input still be parsed correctly? So the parser works. And maybe it's not the most sophisticated of parsers, but it does the job, and it's reasonably easy to grasp. So let's just rename it a little bit. Or maybe just combine. Okay, so this is working. Now the trick is I only have written the parser for action and question. Let's also write a parsing block for the fork. And let's see if we can provide it in the input. I should probably start a new branch, shouldn't I? So fork should be a little bit harder to implement because we have this full branch. But you know what? Before we do that, I've been thinking a bit about how I have the fork implemented. And I don't really believe we need branch to be defined like that. A fork could just be this. The reason I think so is we don't really need to expose the ValentPoint to the user. We don't really need to expose the concept of a branch to the user. The user is only interested in providing a list of skewer blocks to the fork. And skewer blocks are defined somewhere. Where is it? Here. Oh, of course. So maybe before I proceed to implementing a parser for a fork, let's simplify the code and let's remove the branch. Let's see what breaks. So the objective I have for myself for this week is to write a reasonably simple parser for the input so I can iterate and experiment with different layouts and different combinations of skewer blocks and terminators, etc. And if time allows, start working on rendering the connections between skewer blocks and terminators, and etc. So this will undoubtedly produce many errors, but we've seen many errors before. So we don't need to render a branch. But we will borrow the implementation of this render in the fork implementation of the renderer type class, which is somewhere here. Render fork. Should this not be moved a little bit like this? I won't know because it doesn't compile. Okay, let's comment it out. This is our fork. So in the case of a fork, the question always gets rendered. Let's rearrange it a little bit to gain some clarity. The reason I was hesitant to delete the branch type is if I do delete it, then I'll have to have a helper function like this. For the collection of skewer blocks. With an origin that produces a diagram. I wonder if this code is the same as this. FST, fault L, single block. It's not the same because origin is different. But as soon as we break it down like this, it will start making sense. And here it's not 0, it's x. So here we can say if null L and here same just with right. now we'll have to implement within units of a list of skewer blocks. And we can do it here. And then height in units. Oh, and by the way, we captured an issue because the ValentPoint might not be of height and width 1. We should have said width in units of an empty branch is the width of a ValentPoint, and height in units of an empty branch is the height of the ValentPoint. So that's good. I'm just a little bit disappointed that these functions need to be helpers as opposed to implementations of render type class. But I suppose we can't have everything. So I'll go ahead and delete this. So we shifted some things around with net zero gain, I believe. But the usage of this should be a bit easier for the end user because they won't have to specify full branch, empty branch. They won't have the exposure to a ValentPoint. So that's good, I think. Let's check the time. Yeah, we should be starting to wrap it up for the day. Bracket. $206. Oh yeah, sorry. This should be better now. 166. Yeah. Now let's make sure we're applying the right thing here. So these should be done. Now these. No, type like that doesn't exist. There's a skewer block singular and a list. No. Two of five. Oh, and yeah, I also made a mistake with fork. The type should be, let's check. Branch. So we're talking about two lists of skewer blocks. Oh yeah, more mistakes. Width in units, height in units. Will this work? No. Oh, and now we need render prime. Render prime. It sounds very serious. Oops. So many brackets. course. And here we need an origin. But not just an origin. Let's define new origins. Yeah, that is a clear indication we have too many brackets. All right, it finally builds. There are some suggestions, but first of all, let's try to run it. And visually, there is no difference. But look at this. If we wanted to now construct the diagram as it used to be constructed, let's get rid of, for now, of the new part, and let's restore the old part. Where we define the diagram by hand. Now it will not compile because we're using some exotic types like full branch. So what we need to do is to get rid of this, of the full branch, and just use a list of skewer blocks. And here okay, so what, and also here this can go, and this can also go. So this simplifies our diagram. by a large margin. Refresher. This is what we used to have. Now we only have this, which in my opinion is way easier to read. We can also do this. What was that warning? Ooh. So we'll be correcting all this in future sessions, but for now, let's just focus on getting this to compile and to run. Total width in units 3. Yes, because remember, we're dealing with the old diagram. Oops. Yes. Ooh. Let's format it. So the formatter decided for us, and the diagram is not looking bad for such a complicated thing. Let's simplify it again. And I'll also have to comment this out, or comment this out. So now so even though it's not a correct drakon diagram, we'll leave the question just hanging like that without a fork. Oh, so we have the incorrect order. Instead of action, action, question, action, we have action, question, action, action. But we can correct that, I believe. That is because of the fold. Yes, perfect. All right, so let's wrap it up for today at this stage, where we know the fork is simplified and we can define it a little bit easier as the input string. And during future sessions, we'll implement a fork parser for the skewer block, and we'll move on to maybe rendering connections, but that's to be decided. For now, I would like to thank you very much for your attention. I hope you have a great week ahead, and I'll see you next time. Take care. Bye.